Hi there, this is Penelope. This is FS3128 Topic 11 Class 3. This is the last class of integration where we've just looked at it very, very lightly, but it's going to allow you to be able to integrate functions that are a little bit more tricky than the ones that we covered in the previous two classes. This is also the last video for the course. Here's where we're going to now integrate, where we've got a function inside a function. And there's quite a simple way to do these, and it just works. It's amazing. It's an amazing process. When you go on a little bit further in maths, you'll see a little bit more about why it works, but for the moment, it's an amazing process that we can do. Now, at the bottom of the screen, you'll see some work. That's the work to do in class, not now, but it is the page references if you're looking in the textbook. So I will do these on the next slide. What we do here is we're kind of forcing the problem that we're faced with into something that we can do from the list. So we would know what to do if it was x to the power of 4, but it's not. It's something else to the power of 4. So if we rename that bit, if we just rename it as, say, u, then I can rewrite my original question, but I've got a problem because I've got a u and I've got an x, and I can't do that. So I need to find some expression for dx. Now I know that if I find du by dx, look, there's dx there. It's in the wrong place, but it's certainly dx. Right, du by dx is 3. So rearranging that, so du equals 3 dx, and dx equals du over 3. Now I can put that in place of dx. So now I've got u to the 4 times du over 3. I can put the third out the front by one of those rules, and I'm good to go. I can integrate that because my variables match. So now I can say that that's equal to a third times u to the 5th over 5 plus c. So replacing u with what it was, 3x plus 4 to the power of 5 over 3 5s are 15 plus c. Let's have a look at the next one. Let's make the substitution. Let u equal 1 minus 4x. So that means I can rewrite my problem as the integral of u squared dx. Again, I've got two variables, but I know that if I find du by dx, I've got my dx. So that's equal to negative 4. Rearranging du by dx, I can say that du is now equal to negative 4 dx, and dx is equal to du over negative 4. So I can put that into here. So I've got u squared, and dx I can rewrite with du over negative 4. So now I'm going to put the negative quarter out the front, and I'm integrating u squared du. Easy. It's going to be negative a quarter times u cubed over 3 plus c. So I can substitute back. That would be negative 1 minus 4x cubed over 12 plus c. I think I'll do the last one down the bottom here. Give me some space. So it's the integral of 3 sine 2x plus 1. The first thing I do is I put that 3 out the front. Now we know how to integrate sine x, but we don't have x, we have sine of something else. So it would make sense to make a substitution. So now I can write my original question, as the integral of 3 times sine u. I've got a problem. I've got dx and u, so I need to find dx So I can rearrange that and rearrange it again and substitute dx into my problem. I can take the half out and I'm left with something I can integrate straight off the list. My variables match, I'm fine. So then that's 3 over 2. The integral of sine is negative cos. But I need to replace that by whatever u was 2x plus 1. I'm going to put the negative sign right out the front. And 2x plus 1 plus c.